Every summer, two things go up at the same time: ice cream sales and drowning deaths. So here is the question: does eating ice cream cause people to drown? No, of course not. But this kind of mistake happens all the time in research, in news, in government policy. Today, you will learn the difference between correlation and causation, and you will never confuse them again. So what is correlation? Correlation means two things move together. When one goes up or down, the other follows. There are two types. Positive correlation. Both move in the same direction. Height goes up, weight goes up. Negative correlation. They move in opposite directions. Price goes up. Sales go down. But remember this: correlation only tells us that two things move together. It does not tell us why. Back to ice cream. In summer, ice cream sales go up. At the same time, drowning deaths go up. The pattern looks real. But does one cause the other? No. So what is actually happening? There is a hidden third factor. We call it a confounding variable. Hot weather causes people to buy ice cream. Hot weather also causes more people to swim. More swimming means more drowning. Hot weather is the real cause, not ice cream. Ice cream and drowning have nothing to do with each other. Here's another example. Children with bigger shoe sizes tend to be better readers. The data was real. So do bigger shoes make you a better reader? No. The hidden factor is age. Older children have bigger feet. Older children also read better. Both are caused by age. When researchers removed age from the equation, the link disappeared. It was never real. This is what regression does. It removes the effect of confounding variables. Now let us talk about reverse causation. This means the arrow runs backward. You think X causes Y, but actually Y causes X. Example: people who visit doctors more are often sicker. Does visiting the doctor make you sick? No. Being sick makes you visit the doctor. The arrow runs backward. Always ask, which direction does the arrow point? Here is a real debate today. People who use social media more report higher depression. So does social media cause depression? Maybe. But maybe depression causes people to use more social media. That is reverse causation. Or maybe loneliness causes both. That is a confounding variable. Correlation alone cannot answer this. We need more careful research. So how do we prove causation? 3 ways. First, controlled experiment. Split people into 2 groups randomly. Change one thing, measure the result. This is the best method, but in economics, it is often not possible. Second, natural experiment. Sometimes the real world creates natural comparisons. For example, children born on different sides of a school cutoff date get different amounts of education. Comparing their incomes later tells us the effect of education. Third, regression with controls. Add all confounding variables to your model. If the relationship still holds, it is more likely to be real. This is the most common method in economics. Every time you see a correlation, ask 3 questions. Could a confounding variable be causing both? Could the arrow be running backward? Could this just be a coincidence? If you cannot answer all 3, you cannot claim causation. Let us summarize. Correlation means 2 things move together. Causation means one thing actually makes the other happen. Correlation does not mean causation. Ever. The 2 biggest traps are confounding variables and reverse causation. To prove causation, you need experiments or controlled regression. Now let us test your understanding. A headline says, cities with more parks have lower crime. So building more parks reduces crime. Is this correct? Pause the video. Think about it. The answer is coming. Here is the answer. First, this is correlation, not causation. They move together. That does not mean one causes the other. Second, wealth is a confounding variable. Richer cities build more parks. Richer cities also have better policing and lower unemployment. These reduce crime, not the parks. Third, reverse causation. Low crime cities have more money, so they build more parks. The arrow runs backward. If you got all three, well done. Next video, hypothesis testing. This is the tool that tells you whether a result is real or just random noise. Think of it like a courtroom. The data has to prove its case. If this helped you, please like and subscribe. New lessons every week. Simple, clear, to the point. See you in the next one.